Now we've created our ACM certificate. It's time to reconfigure our demo applications. They can be found in the examples subfolder. So right here, we click under the default backend because it will be the first one to be installed, and navigate up to the ingress section. And under the ingress section, you need to pass the certificate ARN. So copy the certificate ARN from the console and just paste it here. This is the ACM certificate that we created. Do the same for the game and repeat the same for the Bloom demo. Once you've done this, you are ready to install the default backend, which will install our application load balancer right here. And it will be an internet-facing load balancer. So let's install it. After we've applied this manifest, we can go ahead and review the logs of one of these pods and just see what is happening while the application is being provisioned. Something else critical to check before you apply this manifest: make sure your domain name matches the domain name that you configured for your certificate. If not, you'll get issues. And also make sure this domain name is correctly spelled. For the default backend, we are using the wildcard so that it captures everything. Anything that we have not set up a subdomain for will fall under this match, and then it has the lowest priority so that it allows any other applications that are installed to have a higher priority, and it will only catch requests that are not captured by our other applications. That's why it's called the default backend. Then now when you check the demo, it has a complete subdomain. When you check the game, it has also a complete subdomain that we added. And both for the game and the Bloom demo, you can see they have a higher group order, and that means that they'll have a higher priority than the default backend, and thus they'll be loaded instead of the default backend. Something to watch out for is when you have multiple users sharing your Kubernetes cluster, let's say in a team, you need to make sure that you use Kubernetes role-based access to limit what these users can do in each namespace. Because if user 1 created a game app and used this subdomain and gave it a priority of, let's say, 10, or a group order of, let's say, 10, and then user 2 created a different app, gave it the same subdomain and gave it a priority of, let's say, 1 or 5, which is lower than the one that user 1 created, it means the second resource that has been created by the second user will have a higher priority than the first resource. And whenever the user 1 tries to load their resource, they'll be loading the resource that has been installed by user 2. So you need to add role-based access to limit which users can install resources in what particular namespace. And this way you can have control where given subdomains have been used within your cluster. So let's go forward and install our default backend. Here we are using kubectl. You can decide to convert this manifest to a Helm valid chart and then install it using Helm. But to keep things simple and also clear, we decided to go forward with the manifest approach. So we'll just say kubectl apply. And since the default backend manifest already has a namespace specified and the default namespace is usually available, we can just apply the manifest without worrying about the namespace. So we'll just select it from the examples folder, and we are installing the default backend. So we'll apply the manifest, give it time to install and create the resources. Once they are created, we can just check the default namespace. You don't have to input namespace because the default namespace is the one selected by default. So when you get all, you can see it's pending. For Fargate, you need to give it time for the Fargate compute to be provisioned before the pod can be ready. You can check the same from the UI on the AWS console. It will show you when the Fargate compute has been provisioned completely, and then at that point the pod will be able to run. I'll check again, and after a few seconds or after a minute or so, you can see our pod is now running. And it also has its service provisioned. It also has its default backend deployment and also the replica set. Now what we are going to do is to check the logs of the load balancer controller. And this was our previous command. So we'll just follow the logs, see what has happened within our controller. This particular pod doesn't have any active logs yet. You can check the other one. and it's the one with them. And in this other pod, you can see we have some activity. So this is the beginning of the load balancer controller pod, and then it ends somewhere here where it's attempting to acquire a leader. And then once it has acquired a leader, then you see when we installed our default backend, it detected this change. You can see the event source was the controller, and then it started creating the target groups, and then it created the ELB security group, added the listener rule to our load balancer, and you can see all this activity. Then at the end here, it's showing you the registered targets, which means the load balancer has been created. Let's go to the console and check if our load balancer has been provisioned and whether it's ready yet.